Hey, Algebra 2, we have a system of three equations. We have a black, a red, and a blue equation. We also have three variables, x, y, and z. We're going to use elimination, but we're going to have to do it twice. So it's a little different, but it's nothing that we haven't done before at its core. So as you can see, we have negative 5y plus 5y and negative 5y here. These are going to eliminate really nicely because they're opposite signs and the same coefficient number. So they're when we pair them up, they're going to eliminate nicely. So let's do the top and the middle first. So black and red, as you can see, kept it color coordinated. Hopefully that helps. But as we just go straight down, we didn't have to multiply by anything to the top or the bottom one because we had negative 5y and plus 5y. So as you can see, those eliminate. 4x plus x is 5x. 4z minus z is 3z. And then we just go down for negative 1. So the first part is done. We did the top and the middle. Now we're going to do in the green, we're going to do the middle and the bottom. Again, we don't have to multiply by anything because we have plus 5y and minus 5y. So they're already the opposites. They're already going to eliminate. Well, x minus x also eliminates, and then the y's eliminate. And negative z minus 5z is negative 6z. Goes straight down, we have negative 18. So now we have two totally new equations here in the orange and here in the green. And we want to solve for z and go backwards. So we have z by itself right here. And as we can see over here, we divide by negative 6, and that's going to be 3. Keep that in your back pocket. Because now we're going to plug it in for z over here in the orange, and we're going to solve for x in this new equation. So we have 5x, just like we have 5x over here, plus 3, but we plug this 3 into z right here, and now we're going to solve for x. So you can see x equals negative 2. Now we have z and x, so we can plug it in for y. Wrote it in red. We're going to plug it into this red equation up here. It doesn't matter which equation of these first three that you plug into, but I thought this one looked the easiest because there was no coefficients in front of the x and the z. So as you can see, we plugged in negative 2 for the x and 3 for the z right here, and then we just solved for y. Now we have x, y, z, and I wrote it in an ordered triple. Problem number 8, it's the same idea here. We have three different equations. Not as clear this time as to what we should eliminate. I picked the x's in this case because we had 1x, and 2x. We could easily multiply the black and the red so that they cancel with this positive 2x here in the blue. So let's do the top and middle equations first. Here in the green, I have the black equation and the red equation. I'm going to multiply the top one, multiply this one by negative 1. So, and then I'm going to rewrite it down here below. So x becomes negative x, negative 6y to positive 6y, and plus 4z to negative or minus 4z, and then negative 12 to positive 12. We're following the green arrow going straight down. We're eliminating. The x's eliminate, and we have 7y minus 8z equals 24. I just went straight down and followed the signs in front of the coefficients. So now we did the green. We're going to do the orange, the middle, and the bottom equations. So we have the red and the blue. Again, we're eliminating the x. We got to do the same variable as up here. And we have a positive 2x down here, so I want this one to be a negative 2x. We got to be the opposite sign but the same coefficient. So I'm multiplying it by negative 2. I'm going to rewrite that red equation down here. So now we have negative 2x minus 2y plus 8z equals negative 24. We're going straight down. That eliminates. The y was just coincidental. And then 5z plus 8z is 13z equals negative 39. So now we're going to solve for z. And we get z by itself. We see it's negative 3. Now we're going to plug in this negative 3 to this green equation right here. And we're going to solve for y. So we see 7y minus 8 times, there's that negative 3 for z. And we're kind of work it down, and we get y equals 0. Now we have a z and a y, and we're going to solve for x. Again, picking out of one of these three problems. No coefficient on x and y. I think that one's going to be the easiest. So we have x plus the y is a 0 minus 4z, but z is a negative 3 equals 12. And then just simplify, and we see we have our x, our y, and our z written in an ordered triple. New stuff, we're going to cover it again on Tuesday. So if it doesn't make sense, reach out and remember to set up a Zoom time for Tuesday.